All right, here we go. Unit 6, Lesson 4. I'm going to call this lesson the what power lesson / the log lesson. And we're gonna find out all about what that means in just a moment. But we're going to start, here's the motivation, with the problem that we did in the Desmos activity a couple days ago. A group of cells grows in number as described by the equation y equals 10 times 3 to the power of t. So we start with 10 bacteria, then the next day we have 30, and then 90, and then 270 each day, right? Each day we're growing by 3. And the question I asked was, how long would it take to pass 10,000? And when we did this in class, right, there really was no better way than just sort of a guess in check method, or to like kind of look at a graph till you figured it out. So if we had 10 times 3 to the x, right, instead of to the second, let's erase that with 3 to the x, right, we could like try and keep tracing our fingers along this until we found exactly when that's going to be that it costs, or that it hits 10,000. But in class, what we figured out was okay, 7 is too high, 6 is too low, so somewhere between 7 and 6. So you can go as far as you want here, like 6.5 too high, 6.4 too low, 6.3 too low, 6.25, right? So you can really try and get this down to an insane level of accuracy. Let's say to the 100th place, we have 6.29. And what today is going to be all about, though, is learning how we can solve that for an exact answer. And so let's say I said, okay, solve this equation. Solve this equation, 10,000 is equal to 10 times 3 to some power. We'll just say x, because that's what we're used to. Well, a good first step would be to divide both sides by 10, right? You can do that because the 10s are multiplying. They make 1. 10,000 divided by 10, what we're left with is 1,000 equals 3 to the power of x. And so now we're at a place where we need to develop a new mathematical operation because we don't know yet how to solve for an exponent, right? How do we bring that exponent down? How could we possibly solve exactly? And here's what we're going to do. We're going to introduce this function, and at first we're going to call it the what power function. And so you can imagine if you had a button on your calculator that you could type in the equivalent of what power of 3 is 1,000, it would answer that question. So first, let's think about some what power functions we could do in our head. I'm going to read this out loud, right? The way it's read out loud is what power of 2 is 8? And the answer here is 3, because 2 to the third power is 8. And we can make up a whole bunch of these equations, right? But I want you to really take note of this form, because I'm trying to ease us into the form. This says what power of 3 is 9? The answer is 2, because 3 squared equals 9. And we can keep going. What power of 5 is 1? It's 0, because anything, including 5 to the 0 power is 1. Ooh, some tricky ones here. What power of 1/3 is 9? This is -2, because I'm just throwing in some review examples here that are tricky. 1/3 to the -2 means 1 over 1/3 to the positive second, 1 over 1/9, 1 over 1/9 equals 9. Ooh, so that's a tricky one. You want to be very careful about the order here, because if you see something like this, what power of 16 is 4, a lot of the times you'll just jump mentally and you'll say, oh, 2, because 4 squared is 16. But that's not what the question asked. The question asked 16 to what power equals 4? And this is 1/2, because you'll remember we have 16 to the, let me erase these now so you can see it, 16 to the 1/2 power, you'll remember, is the square root of 16, which is 4. And so we don't call this the what power function. We have a name for it, the log in base b of a. And this is basically asking, right? This is asking the question, what power, and you just kind of, you got to just remember which one is the base and which one is the exponent. what power of b equals a? And the answer is x. So this statement would translate into saying b to the x equals a. And I like to kind of draw an arrow there to remind us. It says b to the x power equals a. And so you just ask yourself, what power of b gives us a? What power of 2 gives me 64? This is actually to the 6th power. 2 times 2 times 2 is 8. Another 2 times 2 times 2 is 8. 8 times 8 is 64, so it's 6. All right, if we had the log in base 3 of 81, right? So I'm going to start slowly replacing this, right? I'm not going to say what power anymore, right? That's training wheels. I'm going to say the log in base 3 of 81, and you need to know that that means 3 to what power is 81? The answer is 4. What power? The log in base 2 of 2 is the square root of 2, 1/2. 6 to the 3rd power is 216. 64 to the 1/3 power, because the cube root of 64 is 4, gives us the log base 64 of 4. And so what you're going to have to do, and this is pretty much wrapping up here, what you're going to have to do, couple things, is be ready to translate back and forth. So I should be able to give you this expression, and you know that it means 6 squared equals 36. That we know the log in base 289 of 17 means that 289 to the 1/2 power equals 17. That this log means 14 to the -2nd is 196. And that this means that 3 to the 4th equals 81. So first level of difficulty is just rewriting them. A little bit harder, right, because you can't really, it's harder to kind of check these, right, is going into logarithmic form. And so the log, what's our base? 64. What do we want to know? When 64 to some power will be 8. And what's the answer? 1/2, because 64 to the 1/2 power is 8. These are things you all know. It's just getting used to this notation. The log base 12 of 144. It's asking what power of 12 is 144. 12 squared is 144. The log in base 9 of 1 over 81 is -2, because 9 to the -2nd is 1 over 81. And finally, the log, so you can have any base you want here, including fractions. 1/12 squared would be 144. So translating these. And so here's just kind of like a quick preview, and this is the finish here today. Flashing back to the original reason we did this, we said we want to know 3 to what power is 1,000, right? That was, if we go way back to the first problem here, that was where we got stuck. We solved for it until we got to that point. So here's what it turns out. Turns out your calculator has logarithmic functions built into them. So if I wanted to know the answer to this question, right, one way to do this, right, one way to do this would be to graph 3 to the power of, and then make that an x, 3 to the power of x, and I could find where that intersects 10,000. And we'll go check that to make sure that's true. So let's do y equals 10,000. And so that's somewhere way up there, right? We can probably calculate. Can I click on it from there, or is that's too far away? So let's do like x goes from 0 to 8. There we go. That should be enough to get it. So we'll confirm our answer there. But here's how, and this is really important that you know how to do this on Desmos. Here's how you calculate a log. You go to functions. It's going to be under miscellaneous. And now you're going to notice 3 things here, right? And this reminds me, I've got a really important point to remember. If you just put log, if there is log and it doesn't say anything, log means the log base 10, right? It's like the most basic one. So what power of 10 is 10? The answer is 1. What power of 10 is 100? The answer is 2. Notice every time I multiply by 10, the exponent goes up by 1. 10 to the 3rd is 1,000. 10 to the 4th is 10,000. 10 to the 5th and so on and so forth. But that was not what we wanted to know. We wanted to know, so notice what I hit there, log base A. So it lets you put this little number in here, the log base 3 of 10,000, or sorry, this should be just 1,000, not 10,000. The log base 3 of 1,000 is 6.2877. And so what this means is 3 to the, and we'll check this right here, 6.2877 is 10,000. You know, you go more decimal places, you get closer and closer and closer to having exactly the right answer there. You can get as close as you want until Desmos gives up and says, fine, 1,000. Check it out right there. That's the right answer. So this is what we're going to be moving towards with logs. Your Desmos assignments today are just about some of the more basic log properties.